Skills, it's the skills needed. It's more of a discipline is what you need to be in the industry. Just a discipline for precision and cleanliness. You need to understand mathematics. I remember when Fred was talking about when we used to come in on the weekends. My dad would show us trigonometry actually being used. Usually when you learn something like trig or geometry in school, it's one of those things that just you never see an application for it. But Fred and I had this opportunity to find out that there are places where you really need this and can't work without it. So math is an important part of this.
I think the math gives you a concept of it gets you in a mindset of problem solving. Because when you're, or even engineering a job, and figure out how to make it. It's just that whole mathematics, science thing helps you think in that direction. It just so math is important. Everybody always tells you about it. Like my brother said, you don't realize it until you actually get to apply it. Why do I, you're taking trigonometry in school and high school. What do I need this for? What am I going to ever use this for? Well, my father showed us. Oh, that's what that's what you use it for. Oh, okay. And then, it's being able to work with your hands. We take a piece like this. I mean, we machine it, but there's always, when you machine, you machine one side and you machine the other side, and there's mismatches between it, so there's handwork and polishing that you have to do. So you're being somewhat diligent with your hands. That's important too. So, and then it's the knowledge of cutting metals. Learning how to cut metals.
And that's something you can't do. You can't learn that in school. It's the only way you can learn something like that is actually just get your hands on it. And that's part of. You can't walk into a place like this with just your school learning and expect to do anything. You have to learn how to cut metal. You have to understand how metal cuts. And the only way you see that, the only way you find that out is actually by just turning a crank, watching metal cut, listening to it, smelling how if it's burning.
And yeah, if a person's got willing to learn, he's got some math background, work with his hands a little bit, just like you and I learned. We learned on the job.
That's the way it's always been done.
Any technical school is going to have plenty of on-the-job training anyway. So
this industry traditionally has been one where you learn by apprenticeship.
Yeah. Most of our training came from actually from my father, because
he went to school for business. I went to school for electrical technology. We wound up both being machinists.
My father told us when we both went to school, take something else because I can teach you everything you need to know about manufacturing.
That's true.
So he said, well, you might as well learn about stuff I don't know about. He was the shop foreman. He wasn't the business owner. So he said to me, take business management, learn how to run a business. And my brother just had passion.
Stop playing guitar.
Stopped playing guitar, and well, the electronics actually worked out well because he diagnoses and repairs machinery around here because everything's now computerized. When sometimes you have a machine down, you don't want to. That's time is money. You can't. You're trying to make deliveries to a customer and you're losing time because you wait for a service guy to come in. So he could.
Most of the time, even with these most complicated machines, it's just a simple thing that goes wrong with it. And if you can spot that, you can save yourself 2 or 3 days. Like, oh, that fuse is blown. Finding something. The skills needed for getting how to start as a machinist. There are several ways you can actually do that. You can actually go to a trade school and you can learn the basics there, learning how to push a crank and how to sharpen an end mill. Or you can start the way I did and Fred did, and just about everybody here, is they start at ground level. They start doing menial tasks. You'll be shipping, you'll be doing packaging, you'll be doing cleaning machines, like all of us have, and then as you work your way up, it's like, hey, cut this piece of metal, or hey, run this job, and after a few years, you will become proficient if you stick to it. Blueprint reading, yeah, it's absolutely important to know how to do blueprint reading, but more so in this day and age is learning how to read CAD models, because the world is changing. Technology in this industry, technology throughout the world is changing. In this industry, if anything, is leading edge, and the technology you need here is, it's not just about doing an orthographic projection reading of a blueprint like that. You actually have to be able to understand how to use CAD systems, CAM systems, CAD being computer-aided design, CAM being computer-aided manufacturing. Machining gets a bad rap. It's one of those things that you're considered a grease monkey if you're a machinist, but it's really the opposite. You have to know just about more than anybody else technically. It's a highly technical industry, and it's an unforgiving industry. If you make a mistake, you can't backspace out of it or use an eraser. You make a mistake or whiteout, you just, most people don't even know what whiteout is anymore.
Correction tape, okay.
But if you make a mistake, you throw it in the scrap bin and you start over, and you just wasted some material.
And time.
So
sometimes it can be a lot of time to make a piece.
So I can't stress the fact that you need to have a good discipline and a meticulous attention to detail.
The training I got from here, from the company they did. The only thing I went and got schooled for was small shop blueprint reading. Everything I needed to know I learned from here. Previous manager taught me, I'd say 75% of what I know. I'd always been very good with my hands, reading books. Math in school was always a top class. Never thought I would use math until I got into computer programming here, and I put pressure on my kids to make sure that they do the math, because you never know when it will come in handy, and even day-to-day things you use math for, and it's my career and I use math every day. Knowing what material looks like when it comes in from the shop, from a metal mill, and then you go and write a program and put it in a machine, and it comes out completely opposite of what it originally started out as, and you can look at that part and say, wow, I took the time, I made that part, and it's going to function and work just the way engineers designed it to work.